Hey, welcome back. This is Mike from Digital Offensive, and you're watching my path to OSCP. However, today we are not talking about the OSCP. We are talking about a project that I want to talk about for a while now and just haven't had time. Actually, this is probably the 10th attempt to try and record this video. And the project is basically creating a Pwn Plug using a Raspberry Pi. Now, this has been done multiple times. There's plenty of YouTube channels out there showing this process. However, what I want to touch on, something that's missing from a lot of those videos, is a lot of those videos are set up where you're on the network and you're doing testing that way, or you're testing solely with the Raspberry Pi. Now, that is good if you're on site and you're actually sitting there and there's no type of network type filtering in place or internet-based filtering in place that your Raspberry Pi can automatically connect, or if you're not doing it like a black box test, like a true red team engagement where they don't know you're there, and they actually give you usernames and passwords and stuff like that to configure into the Raspberry Pi so it has communication on the network. So what we have here is, so how are we going to do that, right? And to do that, we're going to be using a cellular modem. And basically, the cellular modem is from Calix Institute. I did a video about this not too long ago. And this modem is basically running on Sprint, unlimited and unthrottled, right? I've been pushing anywhere between 30 to 100 gigs a month for these modems, depending where I am, what I'm doing. More when I'm on road trips with the kids, because I let all the kids basically stream their tablets through the modem. So, and that causes a lot of bandwidth. So what do we do here, right? Basically, if we're on site and we want to drop our device off and we want to be able to communicate to that device from off-site, or be able to use that device to connect to the internet, things like that, we can send all the traffic through the cellular modem. Now, there is a caveat with this, right? And the caveat is older buildings. If you're deep in the building, then you may not have good coverage with this. The other caveat with this is Sprint's not the greatest service in all areas. Now, around my local area, I'm out in the boonies. Based on their map, I'm in an in-between zone, and I'm still pulling 15 to 20 megabits on average, right? If I got to major cities like New York, Harrisburg, Pittsburgh, Jersey, I've been pulling in upwards of anywhere from 70 to 100, and I think my max has been about 115 so far. This modem is the R10 modem, and I upgraded to the R10 on their sponsorship page, because Calix is it's all sponsorship. Basically, you donate money and you get cool stuff for your donation tiers. And I did that because this modem will fall back to 3G, which 3G is better than no G, right? But it will do 4G and 4G plus. And 4G plus is really just in those major cities where it's available. And I believe the 4G plus goes anywhere around 150 plus megabits, give or take, but I'm not 100% sure. And basically that's going to allow us to basically shovel a shell out from a Raspberry Pi through any network security, because it's not on their network, and communicate with an outbound server. And that allows us to be off-site, remote, at a hotel, at home, wherever we want to be, and connect to the Raspberry Pi and be able to issue commands and tunnel our traffic through the Raspberry Pi into the network. Now, the other piece of equipment we're going to be using is, of course, the Raspberry Pi. This one is the Raspberry Pi Model B version 2. I do have a version 3 that's currently set up and being used by one of my friends for a project. And it's out in the field right now for his testing. Now, with the Model B, B version 2. Some of the downfalls with this versus the 3 is the less memory on the board. It doesn't have built-in Wi-Fi. The Model 3 is definitely the way to go. It makes life so much easier. It's actually approaching the full, in my opinion, it's approaching that full pocket PC area where you're getting to be able to do a lot more for the few bucks you're spending on these devices. But what we're going to do here is, normally we can plug in like an Alpha card. But if I was using an Alpha card and doing wireless hacking, I would really just be using my Wi-Fi Pineapple instead of a Raspberry Pi, as it's made for that. And then basically tethering the Wi-Fi Pineapple to my modem. So just for demonstration purposes, what we would have here is we would have the wireless card plugged in, and we will plug into the actual network through the Ethernet port. And the wireless card will be tethered to our Calyx modem, and we'll go through all this in the actual setup. But we'll tie this to the Calyx modem, and that'll allow us to communicate outbound. And basically, we would do the configuration on here using Kali Linux, which we'll go through in a moment as well. And the Kali Linux will have two interfaces, one being the inside network and one being the modem to get outbound. And that will allow us to basically go through the internet into the modem through a reverse shell, into the Raspberry Pi, and then into the corporate network. Now, what I mentioned earlier about corporate networks having NAC controls and other security controls in place is important to remember, because we may plug into the corporate network and it may not work. So some things we need to think about is, how do we overcome that? Now, a lot of these videos, they're younger kids doing this at their house. But what we could do there is, the most common attack method here is they plug into printers or behind printers. So on the printer itself, if you're acting as a repairman or network closet checking, whatever you're doing, is you can go up to the printer, you can go through the settings and find the MAC address for the printer, and then basically you can configure this device to act as the printer's MAC address. Now, if they have good network admins, that probably will get quickly detected, and you may get your device kicked off the network, which is not a big deal. We could try other methods such as phones. Find an empty desk that has a Cisco IP phone or any type of IP phone. Check the IP phone settings, find a MAC address, unplug the phone, plug this in there, and hide it there. With that being said, what else are we going to be using in this video? The last piece of heavy-duty equipment here we have is a Anker 26,800 milliamp battery pack. Now, this battery pack, normally if I'm backpacking, camping, something like that, this can last me a good solid 3 to 4 days charging my mobile phones, my tablet, whatever I have with me. I don't really use my phones a lot except for pictures and stuff while I'm out hiking, or maybe GPS, things like that. But it does last a very long time. The caveat with it is it does take a very long time to charge too, and it actually comes with 2 charge ports to actually charge it faster. Most times I just plug in one port. But what we would do in this configuration here is, our Raspberry Pi would be on here, our modem would be on here, and we would have this in a project box. Our project box is just a black box, slim box that kind of looks like the back of a printer, like a printer power supply. And the reason we did it that way for these project boxes is to hide along with the printer and the fax machine and stuff like that. If we lay both of them side by side, they look very similar, and most people won't even pay attention if they even look back there. It also works out great too is if we're behind a desk or something using a phone for the MAC address, we can hide these behind a computer or something like that, and it works just as good. Now, the reason I'm using the battery pack as well as those two is, this battery pack has 3 USB 5-volt chargers, which is great because the Raspberry Pi runs off the 5-volt, the modem charges off the 5-volt, and then the other one is, if we want to, we can add in an HDMI screen. Now, this HDMI screen is by Adafruit, and it basically allows you to use non-GPIO because it's a straight HDMI. Now, the downfall of that is you need to have a power source as well. So I can plug this screen into the battery pack as well. This screen is touch screen, so we can do configuration right on the touch screen. Now, for this demo, we're not going to use the touch screen, because if I try to focus the camera on the touch screen, you guys will never see it, and you really lose value. So what I'm going to try to do here is, I have my GoPro set up, and I have next to me here, which you'll see in a moment, a very large TV that I use just for projects like this. All right, so the first step we want to do, right, we're going to take our Raspberry Pi. We're going to take out the SD card out of our Raspberry Pi. Tiny little micro SD. These SD cards I'm using here are SanDisk 16 gig micro SD cards. I'm not too worried about how much space is on them. The image itself takes maybe a gig. It's actually probably a lot less than a gig of space. And then basically the remainder of the space we can use for some logging and things like that. But really, we're just pivoting through these devices into the network to do our attacks. These devices are not that powerful to really be carrying out a heavy load of attack vectors. minor things, yeah, we could do it with that. We can create a couple of scripts and things like that to run off here. But what we're going to be doing here is just using our SanDisk. So plug the SanDisk into my Mac, and what we're going to do here is I found the best image that works for the Raspberry Model Bs to be the Kali Linux RPI one right here. So we'll download this one. And basically use a torrent. So you're going to need some type of torrent device to download them. And I'm going to pause the blog for a moment. Alright, we're back. We got this downloaded. And what we have done so far is we've extracted the image. And we're now ready to install an SD card. So what I've done... Alright. We are back, and we've downloaded the image and we extracted it. And I've started the actual install to the SD card. And I want to show you the install to SD card here, because you may run into a couple gotchas if you're running on Mac. If you're running on Windows, I find the best tool to use on Windows is the Windows 32. It works great. Run it as admin, copy the image over, and it's done within a few moments. Using it on the Mac, we're using DD with a command to basically copy this image over to the SD card. It works. It's very slow. This process took about 15 minutes to do. So, you can see my first attempt here failed, right? It says resources busy. That's because I still had the SD card mounted. I forgot to go to disk utility on the Mac and click unmount. Normally you would see the SD card here and you click unmount. You can see that it's already unmounted because I already unmounted to run through this. Now the next thing you see here is I ran dd bs equals 1m if equals user. So basically the source of the image. So this is the path to the image. And then basically the image I wanted to put it on. So disk 2s1. Now you can get the name of your SD card from going to disk utilities. It will show up here. You can see that my main hard drive, the device name is right here, disk 1s1. If my SD card was here, you do the same thing. You see the name here. You want to make sure you use the correct name because you don't want to be writing that image to a different device that you shouldn't be writing to, especially your main hard drive. Even though you'll get that resource busy message, you don't want to risk it, right? So once we're done, it prompts you for the password if you're on a Mac. For sudo to run that. Once it was done, it created the image. So at this point, we are ready to boot up the Raspberry Pi. However, I want to take a moment to also show you something else, some other configuration we need to do before we get to this point. Now, I mentioned earlier, we're going to use the Calyx modem to shovel our shell outbound, right? And to shovel our shell outbound, we need some place to catch it. Normally, if I'm going to be home or if I'm at an office area where I know I have a static IP, I will just basically request a firewall hole punch for my IP to receive that traffic. Now, that's not always the case. If I'm in a hotel, if I'm on the road, if I'm on another modem, another cellular tower, I'm not going to really have the opportunity because of NATs and other restrictions. So there's several services out there that you can look at using. Now, I'm not associated with any services in the sense that they're sponsoring me. I have used a majority of these services before. The first one is from Cloud One Host, and they offer a full Kali Linux Cloud VPS. Now, their pricing is a little bit high for what you get, depending what you think, right? So, the one thing with them is, let me scroll down here so you can see. So I signed up for their $14 plan. Now their $14 plan is actually not $14. $14 AUD, which translates to approximately $17-ish currently US. So it's a little bit more than what it actually shows here when you actually go to do the checkout. Now with this though, you basically get dedicated 2 gigs of memory, which most Kali VM images are set at 2 gigs of memory unless you're changing it. The default OSCP one is 2 gigs of memory unless you up it. One Intel Xeon Gold 6132. I haven't really seen any issues using it yet. 50 gigs of solid storage. That's about what you're normally configuring your Kali image as. 1 gig uplink, 2 gigs of traffic, remote desktop, no VNC console. And where they say no VNC console, it doesn't mean they do not support VNC. They use a program called No VNC, just like they use a program called No Machine for you to be able to connect via remote desktop. And you can rebuild, reinstall, and so on and so forth. This is great. You can have a GUI interface. You can use straight shell, whatever you want to do with that. And they don't care what hacking you're doing. If you're doing denial of service, though, they will terminate your account instantly. In theory, if you're using this service, you should already have permission to do any hacking that you are doing. For this video, we're going to use this service. This is the service I'm currently using, so I will show you using the service. Other services I've used in the past have been VPS Dime. VPS Dime is great. It is $7 a month for 6 gigs. It is a VPS server. I believe you can choose from several locations where with one host, they automatically assign me to France, which is way overseas for me, which I wonder how that plays into some cryptography and things like that, but not a huge issue. Right now, I'm just using it for some testing. With VPS Dime, they were a great service. I used them a lot when I was going to DEF CON Black Hat to create VPN tunnels to serve traffic securely. They say you can't do VPN traffic. If you do it legitly and you're not doing anything malicious, they don't really monitor you on that. However, they do have some type of tie-in to your VPS that they can see what you're doing. I was writing some code for a crypto mining software that I was using back in the day, and the name of the module I called, I guess, is on a restricted list of theirs, and they basically took a screenshot of the process running, showing my my application. So somehow they're tied in. They're definitely monitoring you. So you gotta be careful what you're doing on VPS Dime, what you're storing on them. They were always willing to reactivate my account, but it became such a headache that I eventually moved off of them. The other one was Linode. I haven't used Linode in a few years now. They are the first VPS I ever used, and I love them. I used them for IRC servers, bouncers, vHost, things like that back in the day. It was one of the first shells I used. I kind of liked them a lot back then. Just really haven't gone back to look at them. They kind of moved to the same theory of like AWS, where you're paying per usage hours and things like that. So it's up to you which one you want to choose. You can always look at dedicated servers as well, whatever floats your boat. Or if you're just working out of your house and you know that your modem IP is not going to change often, you can easily set up that way as well. Now, how I get this back there and make sure my IP never changes. First, I get a static IP here. So I can hard code that into my modem, into my Raspberry Pi, and that's good to go. But the other thing you can do is you can set up a domain and set your shell to go to the domain and then basically reverse tunnel that way. Now, if your IP changes or if you want to move location, all you have to do is update your DNS record and you're good to go. Normally, I use this site called afraid.org. So if we go to dns.afraid, I believe it's afraid.org. Let's see if I can find them. Sorry, freedns.afraid.org. Freedns.afraid.org is great. You can either own a domain, or you can come to the subdomain list after you log in. And under the subdomain list, you can select from hundreds of domains that people have made available for anyone to use. So you can create a subdomain off their domain. So for example, if there was a domain called rootmybox.com, you would be able to create a subdomain under that called myreverseshell.rootmybox.com and point to your IP. The DNS here updates very, very fast. I would say normally I see about maybe less than 30 minutes before I can start getting DNS requests in most areas. So this is definitely an option that you can look at using as well. However, free DNS also gets flagged a lot. A lot of companies block them because of malicious uses of this site. So that might already kind of put a black cloud over your testing, because they may start seeing traffic going out to the free DNS and be like, oh, hey, we got things that are matching this. let's block that. All right, now that we have our SD card in our Raspberry Pi, we're going to plug in our Raspberry Pi over to this big screen. We're going to jump over here. All right, so our next step here is we're going to test connectivity from the Raspberry Pi to the Windows, to our OneHost Cloud account here using a reverse shell. Now, one of the things to remember is a Raspberry Pi is an ARM processor. It's not an Intel processor, so you got to be careful which payload you're using. For this example, we're going to use a Python interpreter reverse shell to be able to go from the Raspberry Pi over to our Kali box here. Now, right now, I do have the multi-handler listening, and basically set this up. We're going to use we're going to launch MSF console, right? And once we launch MSF console, all we're going to do is use exploit multi-handler, and basically that handler allows us to handle different payloads. We're going to do set our payload to python/interpreter/reverse TCP, reverse underscore TCP. We're going to set our L host and our L port. Remember, I like to use 443 for outbound traffic. In this case, it doesn't really matter because we're using the cellular modem. However, we don't know what Sprint blocks. So we know 443 is allowed out. So let's keep with 443. And currently we have our listener here listening. I want to jump over to the other screen right now where we're going to build the MSF Venom payload and go from there. Alright, so we're running our MSF payload and we're building it. Alright, so we're going to hit enter here, and that's going to build our payload. Alright, so we were able to create a payload called rpython.py, and what we're going to do now is we're going to run this payload. So to run the payload, we're going to type in Python and then rpython. We're going to hit enter. Oops, helps if I can type Python correctly. It's a little hard with one finger. One hand, I mean. Python. Alright, so that's going to execute now. And what we're going to do is we're going to jump over to our other machine and we'll be able to. Alright, so you can see that we were able to send the Python shell across over to us. So now if we do shell, alright, we don't have a TTY, but you know, we can fix the TTY issues, right? Alright. So now we have a full shell over on this host. Let's just make sure it's actually that host and not my local Kali box here. Alright, so yep, you can see that that's tied over to the 192.168.124. 192.168.128.24, and that's the IP address that modem's giving out. We're not connected to any internal interfaces right now. I can run a wire over to my internal network. Alright, so we have ran a wire over to our Raspberry Pi here. And we are now on my local network as well. So from externally, we'll be able to reach the internal network. So next thing I'm going to do is I'm going to spin up a vulnerable VM, and we're going to pivot from my Mac through the interpreter into the Raspberry Pi and attack that VM, just to simulate a real-world attack. All right, so we're now back onto our interpreter shell. As you saw, that we now have connectivity to our local network, to the 192.168.1 network, and basically we're connecting from our OneHost Cloud VPS machine, and we're going over our 4G carrier into the Raspberry Pi into that remote network. So basically, if this is a real world scenario, I have walked into the facility. I've been able to get through some social engineering or just allowing being on site for the engagement. I found a place to plug this device into. I plugged the device into. I made some configuration changes locally if I needed to, such as changing the MAC address if we needed to, and or adding credentials if I needed to. In this scenario, we did not have to do either. But if you did need to change the MAC address, if we did need to change the MAC address, we can use a tool called Mac Changer. Basically, you can just do an apt-get install Mac Changer, and you can use that tool to change it, or you can use the ifconfig tools to change it manually. All right, and basically, remember how I said we can go about getting a new MAC address is if we needed to, is we can try to mimic the printer, copier, fax machine, whatever it is. Most of them have some type of network settings page. A lot of them are not locked down, so you can do that. If that's not an option, you can always look at using the IP phones and logging into there. There's usually a setting there. A lot of the Cisco phones that we still run into are still running Cisco for the network configuration. And you'll be able to view that data. So in this scenario though, because it's my home network, I don't have anything crazy like that. I have my own VLAN for all this type hacking stuff. So if I was to be compromised in my virtual environment, that virtual environment doesn't expand across over to my home network where everyone else sits and plays. So the first thing we want to do here is we want to add a port forward. So if we do a port forward -H, right, just to get the README. And what we want to do here is we're going to do a port forward -L, because we want a forward local port listen to. And we're going to say forward local 8080 to remote 80 to the IP address for remote host connected. Yep, 192.168.1.12. So at that point, we're going to, as I said, we're going to go through the internet from one host cloud through the 4G reverse shell back to us into the Raspberry Pi and then into the CU Office network for port 80 traffic. Now, I have a VM sitting there. It's not a true vulnerable VM yet. I'm building a vulnerable VM to be released at a later date called Heaven's Door. And basically, it'll be a multi-level challenge, like a boot to root CTF. I'm not sure if I'm going to submit over to Hack the Box yet or over to one of the other services that are often capture the flags. I just kind of want to challenge myself and build a vulnerable VM. We're not going to actually exploit it today because I don't want to give any of that away, but just so I have something to connect to. Let's see here. I have missed the word add. So you have to add it in. So you have add delete list. So we're going to add this into it. Okay, so now we have a local listener running. So from here, we want to launch our web browser. Now remember, this is super slow because we're doing a lot of GUI stuff over a slow link. I do live in the boonies, so the connection with the 4G is definitely not the fastest speed right now. And we're running remote desktop virtually on a VPS that's sitting in France. So we are definitely pushing the limits of network connectivity right now. All right, so you can see that we did get this to load in limbo or purgatory, right? So it came up, looks like I have a broken image I need to fix, or that image didn't come across the tunnel here, so I'll have to take a look at that. But if you come over here, you can see that basically it matches similar to this, which is running on my local machine, so it's working through the tunnel. Now, what else can be done with this, right? So we're able to tunnel this, but what other traffic can we tunnel, right? So we can tunnel some of our Nmap scans. We can run some basic scans off the Raspberry Pi and do some connections that way as well. But at this point, we have a full working reverse tunnel over a I call it an out-of-band solution. So we're not relying on our customer's network to have connectivity to this access point. And now we can access this remotely. Some things we can think about for security, securing this device a little bit better, right? We definitely want to change the password. We want to lock down the services. The 4G is pretty good between point A and point B, but in our payload, we can also encrypt our payload using SSL certs or other encryption methods. It's going to add a little bit of overhead, but in the end, it adds that layer of security to the solution. As we start adding more, or as we start mapping and testing more, we're now able to add additional port forwards, open up all the tunnels in here that we can do some additional exploitation or testing, and eventually send all our Kali attacks that we're going to launch across this tunnel into that network for that access. Now, this is definitely not a true replacement of a true Pwn Plug. Those are designed explicitly for this purpose. This is just a cost-effective, cheap way to drop these devices into remote networks for some basic testing. If you're just really getting into it or you're looking for a low-key route, I definitely still suggest you look at the Pwn Plugs as well. This is definitely helpful, but you gotta realize these things become a little bit buggy. You'll start eventually over time getting write issues to your SD cards, depending on how much you're using them and things like that. With that being said, Some things you can look at too is making sure you buy some higher end quality SD cards. The SD cards I'm using right now, I got them on sale for about maybe $15 a piece, maybe a little bit less than that. And I think it was actually a pack of 3 for 15 or something. So they are pretty cheap that I got, but they've been working good enough. As I said, I'll post all the items that I've used in this video below. If you find any interest in it, feel free to follow those links. If you have any questions about how we went through this setup, I'll try to post as much information in the description of the video as well. But let me know what you think about this video. Is this something you like? Do you want to see more of these videos? Comment below, let me know. Alright, until next time, make sure you subscribe if you haven't subscribed yet. Like the channel, share it out with your friends. I look forward to seeing you at the next video.